Hello students, I hope you are doing great. This topic is about memory allocation which will be very much helpful for your different kinds of examinations along with your semester examination. Memory allocations means we know in case of array, that is static allocation, when we are giving the memory locations, when we are reserving the memory locations during writing our program, that is static memory allocation. When we will give the memory locations reserved during the execution of the program, that is called as dynamic memory allocation. That is what we are going to read now. It includes changing the size of an array. As I had told already, arrays with when array is declared, some memory locations are going to be reserved. But here we will change during execution of the program, during the runtime. One example is here. There is an array of 9 elements with 9 reserved memory locations. Of 9 elements with 9 reserved memory locations. Suppose XYZ is the array name and we have given size 9. That is 9 memory locations are reserved. But there is need of 3 more elements. Suppose I am wanting to add 3 more elements into it. So that is what how can I add these 3 more variables or 3 more values into this array with 3 more locations where 9 memory locations are already reserved. That is what my 12 elements will be added to the XYZ array. This is dynamic memory allocation in C, where so where the memory can be defined as a procedure. The size of data structure array is changed during runtime. What I had told, this is what dynamic memory allocation is, the procedure in which we will change the size of the array during runtime. There are 4 library functions defined under header file stdlib.h, where we will use these 4 functions. These are malloc, calloc, free and realloc. It is memory allocation. It is contiguous allocation. It is free when memory is allocated. After our execution of the program, we will make the memory free, and reallocation when some memory is allocated and again we are wanting to give we are wanting to increase those allocation, when the using this malloc and calloc to some locations of the memory is reserved, and in case of by using realloc we can increase that. Suppose it is 9, through calloc and malloc, if we want to change it into 15, so we will use realloc. The definition is like this. It is used to malloc is memory allocation. It is used to allocate single large block of memory with specified size. Large block of memory will be allocated, but it is single. Its syntax is ptr type star malloc byte size. That means one example is here, ptr int star malloc 100 into size of integer. Size of integer is 4 in case of 64 machine. So 100 into 4, the statement, this line will allocate 100 into 4 is equal to 400 memory addresses that will be stored into ptr. Similarly, calloc means contiguous allocation. It is used to allocate specified number of blocks of memory. In malloc it was single block of memory, but in case of calloc it is number of blocks of memory. It will initialize each block to 0. It will initialize each block to 0, and it has two parameters or arguments, that is number of blocks of memory and the size. Its syntax is like this: ptr is equal to type star calloc n comma size, what I had told. Similarly, in case of free or deallocation of memory, when we are allocating through calloc and malloc, after use of the memory, we are wanting to deallocate these memories by the free function. The memory allocated using function malloc and calloc is not deallocated on their own. So deallocated on their own. So hence free function is used to deallocate, which help to wastage of memory. So syntax is free ptr. This is the syntax. Another concept is reallocation method. If the memory is allocated previously with the help of malloc and calloc, if the memory is allocated by malloc and calloc function, and then the user or programmer is feeling that some more memory locations are required, so that is why we will use realloc. This is the function which will increase the runtime, will increase the size of the allocation in runtime, which is allocated by calloc and malloc in runtime. If the memory is allocated previously with the help of malloc and calloc is insufficient, so realloc will present some new block of memory with the existing. Syntax is just like ptr realloc ptr new size. Example, ptr is equal to realloc ptr, suppose new size. This is the xyz. Maybe what? Any number. Maybe 5, 7, 9, 101, something. These are the xyz. Where ptr is reallocated with new size xyz. One example we are giving here: to add two numbers and add n numbers by using allocation techniques, that is by malloc function. And this is what we are doing, int main, and I had told that this memory allocation will go through the stdlib.h header file. So stdio.h, stdlib.h, int main, printf, enter numbers of elements, that may be %ld ampersand n. This should be declared here, int n, and ptr is equal to int star malloc n into size of int n. This is, suppose it is 32 machine, so this will be 2n. Suppose it is 64 machine, this will be 4n. N is dynamic, any number you want. Suppose we will take 3 numbers for addition, so it will be 12. 12 place will be reserved. Here it will be 6 place will be reserved. So we will check if ptr is equal to null, that means unable to allocate the memory. Otherwise, printf enter the elements of the array. For I is equal to 0, I less than n, I plus plus, we are using loop here. so that we will get the input percentile d ptr plus I, percentile d ptr plus I. Suppose we are getting three values, so it will be 0 1 2 3 values. So suppose ptr is equal to first location, ptr is equal to first location plus 0 will be accessed by the percentile d. Then sum plus is equal to star of ptr plus I. This value will be accessed with the value. This address will be accessed with the value here. So this value will be again and again that will be added. So at the end sum will store the n number of elements. Sum will store addition of n number of elements from these two statements. So printf percentile d sum free ptr, then we will, after using our concepts free ptr, then the deallocation is done here, the allocation there, and it is there. And we had on the output it will be shown like enter the number of elements of array, that is 4, enter elements 10 20 30 40, and sum will be 100. Similarly we can explore reallocation, calloc, and it is done, this program is using malloc, so this we can also explore. Please, if time permits, look at it, and we are going to execute those two other programs. On this diagram I am giving you only the programs, please check it.